Faraday's law, the EMF electromotive force induced in a closed path is equal to the time rate of change of magnetic flux linking with the closed circuit path. EMF is equal to minus n d pi by dt. If number of turns is n is equal to 1, then EMF is equal to minus d pi by dt. In electrostatics, EMF induced is measured in volts. E is equal to closed integral E dot dl. The magnetic flux passing through a specified area is given by pi is equal to integral s b dot ds. EMF is equal to minus d pi by dt is equal to minus d by dt integral s b dot ds. From equations 2 and 3, E is equal to closed integral E dot dl is equal to minus d by dt integral s b dot ds. The two conditions are present. First one, the closed circuit is constant. The magnetic flux is varying sinusoidally with time. The magnetic flux is varying sinusoidally with time. The magnetic flux density varying with the coordinate values and time. The partial derivatives are used. That is, the closed integral E dot dl is equal to minus integral s dou b by dou t dot ds. Stokes theorem, the line integral is converted to the surface integral, so that closed integral E dot dl is equal to integral s del cross E dot ds. So that integral s del cross E dot ds is equal to minus integral s dou b by dou t dot ds. So that the surface integrals at both sides are equal. So that del cross E is equal to minus dou b by dou t for the time varying fields. But in electrostatic, for the static field that is not varying with the time, del cross is equal to 0 and closed integral E dot dl it is equal to 0. The magnetic field is kept constant. Not varying with the time. The closed circuit is revolved around it to get the relative motion between the two. The point charge q is moving with a velocity v in a magnetic field B. The force acting on the charge is F is equal to q v cross B. The force per unit charge is equal to the motional electric field intensity, so that the E is equal to F upon Q is equal to V cross B. Then EMF induced E is equal to closed integral E dot dl is equal to closed integral V cross B dot dl. Both closed circuit and the magnetic field are varying. So that E is equal to closed integral V cross B dot dl is equal to minus integral S is equal to closed integral V cross B dot dl minus integral S dou B by dou t dot ds. A conductor 1 centimeter in length is parallel to z-axis and rotates at a radius of 25 centimeter at 1200 rpm. Find the induced voltage if the radial field is given by B is equal to 0.5 AR Weber per ampere meters. The conductor is parallel to z-axis. The radius of a conductor is 25 centimeter, rotates at 1200 rpm. So that here the 1200 rpm is equal to 1200 upon 60 is equal to 20 revolutions per second. The circumference of conductor, because rpm is revolutions per minute, in seconds it is 20 revolutions per second. The circumference of conductor is 2 pi r. So that the velocity of conductor is v is equal to 20 into bracket of 2 pi r, it is equal to 40 pi r. R is radius of the conductors. Conductor rotates in pi direction, so that v is equal to 40 pi r a pi. B is equal to the B is equal to 0.5 AR, so that here V cross B is equal to 40 pi R A pi into 0.5 AR, so that from that one V cross B is equal to 40 pi R into 0.5 is equal to A pi into AR, so that V cross B is equal to 40 pi R into 0.5, it is equal to the minus AZ. So that V cross B is equal to, because in cylindrical coordinates A pi cross AR is equal to minus AZ, since R is equal to 25 centimeters, 25 into 10 raised to minus 2 meters. So that V cross B is equal to minus 20 pi R AZ. DL is equal to DZ AZ is parallel to Z axis. So that the EMF induced is equal to closed integral E dot dl is equal to closed integral V cross B dot dl closed integral minus is equal to 20 pi r AZ dot dz AZ is minus 20 pi r dz AZ dot dz. EMF is equal to minus 20 pi r dz. E is equal to minus 20 pi r bracket of z 0 to 0.01. E is equal to minus 20 pi into 25 into 10 raised to minus 2 into 0.01 minus 0.157 volts. So that length L is equal to 1 centimeter. E is equal to 0.01 meter. E is along z axis. A circular loop conductor lies in a plane z is equal to 0 and has a radius of 0.1 meter and resistance and has a radius of 0.1 meter and resistance of 5 ohm and a resistance of 5 ohm. Given B is equal to 0.2 sin 10 raised to 3 t AZ, determine the current in the loop. E is equal to EMF is equal to minus integral s dou B by dou t dot ds. B is along z directions. ds it is along z directions, so that the surface ds is equal to r dr d pi into bracket of AZ. E is equal to minus integral s dou by dou t is 0.2 sin 10 raised to 3 t into AZ dot r dr d pi AZ. Here it is the x directions, y directions and z directions, cylindrical coordinate systems. E is equal to minus integral s 0.2 into 10 raised to 3 into cos 10 raised to 3 t into r d pi dr AZ dot dz minus 0.2 into 10 raised to 3 cos 10 raised to 3 t pi is equal to 0 to 2 pi, r is equal to 0 to 0.1 r dr d pi minus 0.2 into 10 raised to 3 cos 10 raised to 3 t r square by 2 0 to 0.1 pi 0 to 2 0.2 10 raised to 3 cos 10 raised to 3 t upon 2 0.1 square into 2 pi. Current in the loop is the I is equal to EMF induced upon a resistance. EMF induced upon a resistance I is equal to minus 0.628 into cos 10 raised to 3 t upon 5 minus 0.125 cos 10 raised to 3 t ampere s minus 0.125 cos 10 raised to 3 t. So that minus 10 raised to minus 3 into 10 raised to 3 cos 10 raised to 3 into 2 minus EMF induced is E is equal to minus 6.28 minus 6.28 into cos 10 raised to 3t volts. The concept of the displacement current. The curl of magnetic field intensity is equal to the current density, so that del cross H is equal to J. But according to vector identity, the divergence of the curl of a vector is equal to 0. The del cross H is equal to del dot J is equal to 0, but del dot J is equal to minus dou rho v by dou t. Dou rho v by dou t is equal to 0 is not true. Is not true, is not compatible for the time varying fluids. Another term n is added to the right hand side of equation. Del cross H is equal to J plus n. Del cross H is equal to del dot J plus n. Here del cross H is equal to del dot J plus del dot n. Del cross H is equal to minus dou rho v by dou t plus del dot n. Because the del dot J is equal to minus dou rho v by dou t is equal to rate of change of the volume charge density. Del dot n is equal to dou rho v by dou t, so that according to the point form of Gauss law, del dot D is equal to the volume charge density. Del dot n is equal to dou by dou t del dot D. Del dot n is equal to del dot dou d by dou t. N is equal to dou d by dou t. The equation 3 can be written as the del cross H is equal to J plus dou d by dou t. Del cross H is equal to Gc plus Jd. Gc is conduction current density. Jd is displacement current density. The electrical circuit consisting of parallel combination of resistance and capacitance. I1 is equal to V upon R, that is current through the resistance, and the IC is equal to I1 by A, GC is equal to I1 by A, E is equal to V upon D. Here V current I1, here it is current I2, and this is equal to sigma I. Current through the capacitance is I2 is equal to C dV by dt. C is epsilon A upon D dV by dt, but E is equal to V upon D. I2 is equal to epsilon A upon D into dE by dt. So that epsilon A dE by dt, epsilon A dE by dt, Jc is equal to sigma E, because I1 is equal to V by R, Jc is equal to I1 by A, but E is equal to V by D. So that here the Jc is equal to sigma E. From all these parameters, this I1 by A, from all these parameters, Jc is equal to sigma E. Current through the capacitance is IC is equal to C is epsilon A upon D, but E is equal to V by D. Here epsilon A dE by dt. So that ID is equal to the I2 upon E is equal to epsilon dE by dt is equal to d by dt. But E is equal to E, but D is equal to epsilon. But if E is equal to E raised to j omega t, from that one the Jd is equal to omega epsilon E. So that sigma upon omega epsilon greater than or equal to 1 conductor, sigma upon omega epsilon is less than or equal to 1, it is dielectrics. So that the Jc by Jd is equal to sigma E upon omega epsilon E is equal to sigma upon omega epsilon. That is the ratio of these two. The Maxwell's equations. The differential forms del cross E is equal to minus dou b by dou t dot ds, and del cross h is equal to gc plus dou d by dou t, and del dot d is equal to rho of v, and del dot b is equal to 0. Here closed integral forms closed integral E dot dl is equal to minus integral dou b by dou t dot ds, and closed integral h dot dl is equal to I plus integral dou d by dou t dot ds, and here del cross is equal to minus dou b by dou t dot ds is closed integral E dot dl is equal to minus integral s dou b by dou t dot ds. Del cross h is equal to jc plus dou d by dou t is equal to closed integral h dot dl is equal to I plus integral dou d by dou t dot ds. Del dot d is equal to rho of v is equal to closed integral d dot ds is equal to integral v rho v d dot b is equal to 0, so that closed integral s b dot ds is equal to 0. Find the frequency at which conduction current density and displacement current density are equal in a medium with sigma is equal to, and epsilon r is equal to 81. So that Jc by Gd is equal to sigma upon omega epsilon is equal to 1. Sigma is equal to omega epsilon is 2 pi f into epsilon. Sigma is equal to, from that one, the frequency is equal to 44.38 kilohertz. Find the frequency at which conduction current density and displacement current density are equal in a mediums. In a lossy dielectric medium, the conduction current density Gc is equal to 0 to ampere. Find the displacement current density if sigma where Gd is equal to sigma upon omega epsilon is Gd is equal to Gc omega epsilon naught into r upon sigma, so that Gc is equal to Gc sin omega t Gc 0.02. W is equal to 10 raised to 9. Gd is equal to 8.84 into 6. Here Gd is equal to 1.15 microampere per meter square. In a metal for which sigma is equal to 5, the electric field intensity is E is equal to 250 sin 10 raised to T volt. Find the conduction and displacement current densities and the frequency at which both have equal magnitudes. This is equal to sigma E is equal to 5 into 250. This is equal to 1250 sin 10 raised to T ampere per meter square. It is equal to dou d by dou t epsilon E is equal to epsilon dou E by dou t. Gd is equal to epsilon naught epsilon r dou E by dou t is equal to Gd is equal to dou by dou t 250 sin 10 raised to 10 t. It is equal to 8.854 into 10 raised to 10. It is equal to 22.3. Jc by Jd is equal to sigma upon omega epsilon is equal to 1. Sigma is equal to omega epsilon, so that the 2 pi of epsilon naught epsilon r f is equal to sigma upon 2 pi epsilon naught epsilon r. From that one, frequency is equal to 89.8 into 10 raised to 9 hertz. Do the field C is equal to em sin x sin t ay, and the h is equal to em upon mu naught cos x cos t az satisfies the Maxwell's equations. The Faraday's law for the time varying fields is del cross E is equal to minus dou b by dou t, b is equal to mu h. Del cross E is equal to minus mu naught dou h by dou t. Del cross E is equal to ax ay az dou by dou x dou by dou y dou by dou z 0 em sin x sin t 0. Del cross E is equal to dou by dou x em sin x sin t az. Del cross E is equal to the em cos x sin t az plus mu naught dou h by dou t is equal to plus mu naught dou by dou t em upon mu naught cos x cos t az. Dou by dou t is em cos x cos t az minus em cos x sin t az. Del cross E is equal to minus mu naught dou h by dou t. Left hand side is equal to right hand side, so that the given fields satisfies the Maxwell's equations. The given fields satisfy the Maxwell's equations. The retarded potentials. The electric scalar potential is given. The electric scalar potential is given by V is equal to integral V rho V upon 4 pi epsilon r into dV. The magnetic vector potential is given by A is equal to integral V mu J upon 4 pi r into dV. The electric field for time varying fields is given by E is equal to minus del V minus dou A by dou T. D is equal to epsilon E. D is the electric flux density. Del dot D is equal to rho V, that is Gauss law. Del dot epsilon E is equal to rho V. Del dot E is equal to rho V upon epsilon. Del dot E is equal to minus into bracket of del dot del V plus del dot dou A by dou T. Del dot E is equal to minus del square V minus dou by dou T del dot E. Del square V plus dou by dou T into bracket of del dot A is equal to minus rho V by epsilon. The curl of magnetic field intensity for a time varying fields is given by del cross H is equal to Jc plus dou D by dou T. B is equal to mu H. B is equal to del cross A. D is equal to epsilon E. 1 upon mu into bracket del cross A is equal to J plus epsilon dou E by dou T. Del cross A is equal to del into bracket of del dot A minus del square A. Del dot A minus del square A is equal to mu J plus mu epsilon dou E by dou T. Del dot A minus del square is equal to mu J mu epsilon dou by dou T del V minus dou A by dou T. Here del dot A minus del square is equal to mu J minus mu epsilon del dou A by dou T minus mu epsilon dou square A by dou T square. Del dot A is equal to minus mu epsilon dou A by dou T minus del square A is equal to mu J minus mu epsilon dou square A by dou T square. So that del square A is equal to minus mu epsilon dou square A by dou T square is equal to minus mu J. Equation 1 is how the scalar electric potential is related to the vector electric potential. Equation 3 is how the scalar electric potential is related to the vector magnetic potentials. And they put the value of del dot A in equation 2. So the del square V is equal to minus mu epsilon dou square V by dou T square is equal to minus rho V by epsilon. So the del square A is equal to minus mu epsilon dou square A by dou T square is equal to minus mu J. So equation 4 is for scalar electric potentials and 5 is for the vector magnetic potentials. The equations for the retarded potentials for the time varying fields is the V is equal to integral V rho V upon 4 pi epsilon r into dV and the scalar electric potential. Now this one it is the vector magnetic potential A is equal to integral V mu J upon 4 pi r into dV. The terms volume charge density rho V and the current density J within the square brackets indicate that these are time variant. So that the uniform plane waves in free space. Solution of wave equation for free space. The general wave equation is del square E is equal to mu sigma dou A by dou T plus mu epsilon dou square E by dou T square. Ex, Hy and the z directions. Del square E is equal to dou square Ex upon dou x square, dou square Ex upon dou y square plus dou square Ez upon dou z square. The transverse electromagnetic wave Tm, the electric field is along x directions, magnetic field is along y directions. The propagation of the wave is along z directions. Dou square Ex upon dou z square is equal to mu sigma dou A by dou T plus mu epsilon dou square E by dou T square. For free space, sigma is equal to 0, epsilon is equal to epsilon naught, mu is equal to mu naught. Dou square Ex upon dou z square is equal to mu naught, epsilon naught dou square Ex upon dou T square. X is equal to m e raised to j omega t. X upon dou t is equal to m j e raised to j omega t. Dou square Ex upon dou z square is equal to dou square Ex upon dou Z square is equal to mu naught epsilon naught into bracket of minus 1 omega square Em e raised to j omega t. Dou Z square is equal to minus omega square mu naught epsilon naught into Ex. Dou by dou Z is equal to d. Dou square by dou Z square is equal to d square. D square Ex is equal to minus omega square mu naught epsilon naught into Ex. D square Ex plus omega square mu naught epsilon naught into Ex is equal to 0. D is equal to plus or minus omega square root of mu naught epsilon naught. So that the beta is equal to phase shift constant. Beta is equal to plus or minus omega square root of mu naught epsilon naught. Then the solution of the wave equation for free space is Ex is equal to k1 e raised to plus j beta x plus k2 e raised to minus j beta x. k1 is equal to em plus e raised to j omega t. k2 is equal to em minus e raised to plus j omega t. Ex is equal to em plus e raised to j omega t e raised to j beta x plus em minus e raised to plus j omega t. So that Ex is equal to em plus cos of omega t minus beta x plus em minus cos of omega t plus beta x. Em plus is forward travelling view, em minus is reverse travelling view. So that em plus cos of omega t minus beta x plus em minus cos of omega t cos of the omega t plus beta x. Em plus forward travelling view, em minus is reverse travelling view, phase shift constant. Beta is equal to omega square root of mu naught epsilon naught. For the free space, phase velocity is v is equal to omega upon beta is equal to omega upon omega square root of mu naught epsilon naught is equal to 1 upon square root of mu naught epsilon naught. Mu naught is 4 pi into 10 raised to minus 7. Epsilon naught is 8.854 into 10 raised to minus 12 farad per meters. Now v is equal to 3 into 10 raised to 8 meter per seconds. The relationship between the electric field and the magnetic fields. Del cross E is equal to minus mu naught dou h by dou t. Del cross is Ex, Ey, Az 0, 0, dou by dou z. Here it is the Ex minus mu naught into bracket of dou hx by dou t, dou hy by dou t, dou hz by dou t, dou Ex upon dou z into Ay is equal to minus mu naught into bracket of dou hy by dou t into Ay. Dou Ex upon dou z is equal to minus mu naught dou hy by dou t. Ex is equal to em plus cos of omega t minus beta z plus em minus cos of omega t plus beta z. Dou Ex upon dou z is beta into bracket of em plus sin of omega t minus beta z minus em minus sin of omega t plus beta z. Minus mu naught dou hy by dou t is equal to beta into bracket of em plus sin of omega t minus beta z. Em minus sin of omega t plus beta z. Dou hy by dou t is equal to minus dou hy by dou t is equal to beta upon mu naught into bracket of em plus sin of omega t minus beta z minus em minus sin of omega t plus beta z. Minus hy is equal to minus beta upon mu naught into bracket of em plus cos of omega t minus beta z upon omega minus em minus cos of t plus beta z upon omega. So that hy is equal to beta upon omega mu naught into bracket of em plus cos of omega t minus beta z minus em minus cos of minus em minus cos of omega t plus beta z. Hy is equal to hm plus cos of omega t minus beta z minus hm minus cos of omega t plus beta z plus is equal to beta upon omega mu naught em plus hm minus is equal to beta upon omega mu naught em minus em plus upon hm plus is equal to omega mu naught upon beta is equal to omega mu naught upon omega square root of mu naught epsilon naught. Neta is equal to em plus upon hm plus is equal to 1 upon a square root of mu naught epsilon naught. Neta is intrinsic impedance of the medium. Mu naught is equal to 4 pi into 10 raised to minus 7. Epsilon naught is 8.854 into 10 raised to minus 12, 377 ohms. The wavelength lambda is equal to 2 pi upon beta, 2 pi upon omega square root of mu naught epsilon naught is equal to 2 pi f square root of mu naught epsilon naught. 1 upon f mu naught epsilon naught is equal to v upon f is equal to 1 upon square root mu naught epsilon. Lambda is equal to c upon f is equal to c is equal to f lambda. Because v is equal to 1 upon square root of mu naught epsilon naught, so that lambda is equal to c upon f is equal to c is equal to f lambda. The propagation constant is del square E is equal to mu sigma dou E by dou t is plus mu epsilon dou square E by dou t square. E is equal to Em plus e raised to j omega t. Del square E is equal to mu sigma j omega Em plus e raised to j omega t plus mu epsilon j omega into bracket of j omega Em plus e raised to j omega t. Del square E is equal to mu sigma into bracket of j omega into E plus mu epsilon j omega square mu epsilon into bracket of j omega square into E. Del square E is equal to j omega into bracket of mu sigma plus j omega mu epsilon into bracket of E. Del square E is equal to gamma square E. Del square E is equal to gamma square into E. Gamma is the propagation constant, so that gamma square is equal to j omega mu into bracket of sigma plus j omega epsilon. Gamma is equal to square root of j omega mu into bracket of sigma plus j omega epsilon. Gamma is equal to alpha plus j beta. For free space, sigma is equal to 0. Gamma is equal to square root of j omega mu into bracket of the j omega epsilon. Gamma is equal to square root of the square root of j square omega square mu epsilon. Gamma is equal to square root of minus 1 omega square mu epsilon, so that gamma is equal to j omega square root of mu naught epsilon naught. Mu naught epsilon naught, because gamma is equal to j beta. Gamma is equal to j beta. For free space mu is equal to mu naught, epsilon is equal to epsilon naught. For free space mu is equal to mu naught, epsilon is equal to epsilon naught. So that alpha is the attenuation constant, beta is the phase shift constant. Alpha is the attenuation constant and beta is the phase shift constant. And the equation for the uniform plane wave traveling in free space is given in the phasor form. The electric field is given by Ey is equal to 10.4 e raised to j 2.10 raised to 90 minus beta x microvolts per meter. Find direction of propagation of the uniform plane wave, phase velocity, phase constant, propagation constant, and the expression for the magnetic field in phasor form. Ey is equal to 10.4 e raised to j into bracket of 2 pi into 10 raised to 90 minus beta x microvolts per meter. The direction of propagation of the uniform plane wave is in the x directions. Because here beta x, it indicates that the direction of propagation, the electric field, it is component is Ey, but here in the equation it is beta x, so that the direction of propagation of uniform plane wave is in the x directions. So that Em plus is equal to 10.4 microvolts per meters. Omega is equal to 2 pi into 10 raised to 9 t. Now second one, phase velocity. Phase velocity is v is equal to 1 upon square root of mu naught epsilon naught is equal to 3 into 10 raised to 8 meter per seconds. Then the phase shift constant beta. Beta is equal to omega, phase shift constant beta is equal to omega square root of mu naught epsilon naught. Beta is equal to 2 pi into 10 raised to 9 square root of 4 pi into 10 raised to minus 7 into 8.854 into 10 raised to minus 12. Beta is equal to 2 pi into 10 raised to 9 into 3.35 into 10 raised to minus 9 is equal to 21.04. The propagation constant gamma is equal to alpha plus j beta. Gamma is equal to j beta. Gamma is equal to j 21.04. The expression for the magnetic field in phasor form is the electric field is along y directions, the propagation is along x directions, the magnetic field is along the z directions. The electric field is along y directions, the propagation is along x directions, the magnetic field is along the z directions, so that Hz is equal to Hm. The magnetic field is along z directions, so that Hm plus e raised to j into bracket of 2 pi into 10 raised to 9t minus beta x. Neta is equal to Em plus upon Hm plus e is equal to Hm plus Em upon neta. 0.4 upon 10.4 upon 377 is equal to Hm is equal to 0.027. 0.027 e raised to j into bracket of 2 pi into 10 raised to 9t minus 21.04 x ampere per meters. That is the magnitude of the expression for the magnetic field in the phasor forms. The propagation of uniform plane waves in the perfect dielectrics. The conductivity sigma of a perfect dielectric medium is equal to 0. This medium is also known as the lossless medium. The propagation of uniform plane waves in perfect dielectric is similar to the free space except for the difference in permeability and permittivity. The permeability and permittivity of a free space is epsilon is equal to epsilon naught, mu is equal to mu naught. The permeability and permittivity of dielectric is epsilon is equal to epsilon naught epsilon r and mu is equal to mu naught mu r. The phase velocity is v is equal to omega upon beta is equal to omega upon omega square root of mu epsilon is equal to 1 upon square root of epsilon. 1 upon square mu naught mu r epsilon r is equal to v is 3 into 10 raised to 8 upon square root of mu r epsilon r. Intrinsic impedance. Eta is equal to square root of mu upon epsilon is equal to square root of mu naught mu r upon epsilon r. Mu naught upon epsilon naught mu r upon epsilon r is equal to 4.10 raised to minus 7. 10 raised to minus 12 upon epsilon r. Neta is equal to 377 square root of mu r upon epsilon r. Wavelength lambda is 2 pi upon beta 2 pi upon omega square root of mu epsilon. Lambda is equal to v by f. Propagation constant gamma is equal to square root of j omega mu into bracket of sigma plus j omega epsilon. For perfect dielectric, sigma is equal to 0, gamma is equal to square root of j omega mu into bracket of j omega epsilon. Gamma is equal to alpha plus j beta, gamma is equal to plus or minus j omega square root of mu epsilon plus or minus beta. Phase constant beta is equal to omega square root of mu epsilon, attenuation constant alpha is equal to 0. A 9375 MHz uniform plane wave is propagating in polystyrene if the amplitude of the electric field intensity is 20 volt per meter and the material is assumed to be lossless. Find the attenuation constant, phase constant, wavelength in the polystyrene, velocity of propagation, intrinsic impedance, the propagation constant, the amplitude of magnetic field intensity. For polystyrene, the is assumed to be and the material is assumed to be lossless. For polystyrene, mu r is equal to 1, epsilon r is equal to 2.56. For a lossless medium, the conductivity sigma is equal to 0. Then first one, the attenuation constant alpha is equal to 0. Second one, phase constant beta is equal to the omega square root of mu epsilon. Beta is equal to 2 pi f square root of mu naught mu r epsilon naught epsilon r. Beta is equal to 2 pi into 9375 into 10 raised to 6 is 4 pi into 10 raised to minus 7 into 1, 8.854 into 10 raised to minus 12 into 2.56. Beta is 2 pi to 5.33 into 10 raised to minus 9. Beta is equal to 314.37 radians per meters. Beta is equal to 314.37 radians per meters. Lambda is equal to 2 pi upon beta is equal to 2 pi upon 314.37 is equal to 0.02 meters. Lambda is equal to 2 pi upon beta 2 pi upon 314.37 is equal to 0.02 meters. Velocity of propagation is v is equal to 1 upon square root of mu epsilon is equal to 1 upon square root of mu naught mu r epsilon naught epsilon. 2.56 is equal to 1.875 meter per second. V is equal to 1.875 meter per second, that is the velocity of propagations. Intrinsic impedance is neta is equal to square root of mu upon epsilon is equal to 377 square root of mu r by epsilon r. Square root of 1 upon 2.56 is equal to 235.62 ohms. The propagation constant gamma is equal to square root of j omega mu into bracket of sigma plus j omega epsilon. The medium is lossless medium, so that sigma is equal to 0. Gamma is equal to square root of j omega mu into bracket of j omega epsilon. J omega square root of mu epsilon plus or minus j beta is equal to plus or minus j 314.37 radians per meters. Amplitude of magnetic field intensity. Neta is equal to Ey upon Ex upon Hy is equal to 235.62 is equal to 20 upon Hy. Hy is equal to 20 upon 235.62 is equal to 0.0848 ampere per meters. A 300 megahertz uniform plane wave propagates through a fresh water for which sigma is equal to 0. Mu r is equal to 1, epsilon r is equal to 78. Determine attenuation constant, phase constant, wavelength, intrinsic impedance. The given medium is a fresh water, is a lossless medium. The given medium is a fresh water. The given medium is a fresh water, is a lossless medium, for which conductivity sigma is equal to 0. Attenuation constant alpha, it is equal to 0, that is sigma is equal to 0. Phase constant beta is equal to omega square root of mu epsilon, omega square root of mu naught mu r epsilon naught epsilon r. It is equal to 2 pi into 300 into 10 raised to 6. Beta is equal to 55.530 radians per meters. Wavelength lambda is equal to 2 pi upon beta is equal to 2 pi upon 55.530 is equal to 0.113 meters. Intrinsic impedance is neta is equal to square root of mu epsilon mu upon epsilon mu naught mu r upon epsilon naught epsilon r. 377 into square root of mu r upon epsilon r is equal to neta is equal to 377 into 1 upon 78 is equal to 42.68 ohms. The Poynting theorem. The energy is transmitted from the transmitter to receiver. The rate of energy flow is known as the power density. The electric field E is measured in volts per meters and the magnetic field H is measured in ampere per meters. The product of these two, that is volt ampere V volt ampere per meter square or watts per meter square, is power per unit area or power density. The dot product of E and H is a scalar quantity. The cross product of E and H is a vector quantity. The power radiated from an antenna flows in a particular direction. The cross product of E and H. The cross product of E and H is the power density. The Poynting theorem can be defined as the rate of decrease of energy stored within the volume V minus the power dissipated. Can be defined as the rate of decrease of energy stored within the volume V. Rate of decrease of energy stored within volume V minus the power dissipated. Here it is the electric field E, here it is the electric field E, and here it is the magnetic flux density, magnetic flux B, electric field E, and here it is magnetic flux B. So that here it is the current density J, and it is the resistance R, and it is the volume V. Can be defined as the rate of decrease of energy stored within the volume V minus the power dissipated. E is equal to Ex Ax, H is equal to Hy Ay, P is equal to E cross H is equal to Ex Ax Hy, Ax cross Hy. Ax cross Ay is equal to H Az. The direction of power flow is in Z directions, so that Ex is equal to Em cos of omega t minus beta Z Ax. Hy is equal to Em upon neta. Em upon neta cos of omega t minus beta Z into Ay. So that P is equal to Ex, P is equal to Ex Hy Az. P is equal to Ex Hy Az is equal to Em square upon neta cos square of omega t minus beta Z